Hello, we're back talking about Pythagorean theorem applications, and we mentioned how to come up with the distance formula using the Pythagorean theorem. So here's an example of using the distance formula with a couple points in the Cartesian coordinate system. We can say these ordered pairs. And remember, if we're using a little xy axis Cartesian coordinate system, then the coordinate pairs always look like this. The x is first, the y is second, x is first, y is second. Just kind of conventionally. So if that's true, here's an x and a y, here's an x and a y. How do I use the distance formula on these 2 points? Well, I have to choose which one of these points is point number 1 and which one is point number 2. And it actually doesn't matter what your choice is. I could say this is 1, this is 2, or this is 1, this is 2. And either way, the formula will work. So let me just say the one on the left is point number 1. So I'm going to assign this an x1 and a y1. The point on the right is point number 2, so I'm going to assign this an x2 and a y2. And now I'm just going to plug those numbers into the above formula and see what we get. So d is equal to the square root of parentheses x2, 1 minus x1, 8, quantity squared, plus parentheses y2 minus y1, quantity squared. The root is over the whole thing. And then just keep going from here. So this gives me the root of 1 minus 8 is negative 7 in the parentheses squared, plus 4 minus 9 is negative 5 in the parentheses squared. And I have my root symbol there, continuing, equals root of negative 7 quantity squared is 49, plus negative 5 squared, quantity squared is 25. And that gives me the root of 74, which probably doesn't come out to a nice round whole number. But I could say that this is the distance in the end. And I don't know if I'm talking about inches or feet or what, or just units, but keep that in mind relative to the problem. Can this be simplified? I'm just curious. Let me take this 74. 74 is at least 2 times something, 37? I believe that's correct. 37 is anything times anything 37. 1, 2, 3. Get a, let's see, 13 times 3 would be 39. 12 times 3 is 36. So that doesn't work. 4, 5, 6, 7, 8, 9. I can't really see it. So I'm going to say that this actually doesn't simplify due to the prime factorization there. And that's something you can review at a later time. Let me go back to this distance formula, though. Notice that it was fairly irritating, at least to me, to carry this root symbol down the whole time that I'm doing my work. So I prefer to use this one. And I said in a previous video, it's actually a little easier to use in cases like this, where you just have the d squared instead of d by itself. So you don't have to keep messing around with this root symbol. And if I use these numbers, let me do my x2 minus x1 squared plus y2 minus y1 squared, and go from here. This gives me negative 7 quantity squared plus 4 minus 9 is negative 5 quantity squared. That gives me a 49 plus a 25, which is 74. Then in the end, to get d by itself, I take a square root of both sides. I don't need a plus and a minus because we're talking about distance. I only need the positive value. And this is how I would finish using this equation. I would simply say, therefore, d is equal to the root of that thing that I ended up with there. So just kind of a different way to do it that you might like a little bit better. So let me erase this example here, and we'll do one more. And I'll just use that formula there. Or maybe 2 more, I don't know. Edit button, skip ahead. Okay. So let's do another example. Let's just make up a couple numbers on a point. Let's say we've got, I don't know, your favorite 2 numbers. X is 10, everybody likes 10, right? and y is 7. Those are fun. And the other x, let's see, that puts us in the first quadrant. Let's do one in the third quadrant to make a couple negative numbers there. So how about x is negative 3 and negative 4, and see what happens. So to find the distance between these 2 points, again, recognizing that we have an x and a y, an x and a y, I'm just going to label one of these as point number 1. It doesn't matter which. How about this one? We'll call this one point number 1. So I got an x1 and a y1 for the first coordinate pair on my right this time. On the left, we'll call this then x2 and y2, and apply the distance formula. And again, I like to do it in this squared version. So d squared is equal to x2 minus x1. Now be careful here, because I'm not saying 10 minus 3, I'm saying 10 minus negative 3. So you need to say that here in your writing as well. So be careful with that. Plus y2 is 7 minus negative 4. Put a square on that guy and continue. This gives me 10 plus 3 quantity squared. Don't forget, minus and negative is positive. And I've got plus 7 plus 4 here, squared, yada, yada. This gives me a 13 squared plus 11 squared, which is 169 plus 121. And these numbers get too large for me. What's that give me? A 10 here. The 9 and the 1, carry your 1, 8 and 9, 1, 2, 90, right there. So d squared is equal to 290. And then I take a quick square root, or say therefore, d is equal to the square root of 290. Now, I'm not sure if 290 simplifies at all. So let me take a look at just 290 by itself and see if I can possibly simplify this root. Why do I not have a calculator next to me? Who knows? So let's take a look at 290. What times what is 290? 29 times 10 looks like it's 290. I'm going to go down to the prime factorization. 29, that's a prime number. 10 is 2 times 5, so 290 is 2 times 5 times 29. I don't see anything squared here, which means I cannot simplify this square root. So right here, that's it. D is equal to root 290. And I'll erase this here. Or try to. Okay, why don't we continue on to the next video, actually, to get to more applications of the Pythagorean theorem.